This is a branded podcast from Postscript Studios.
Pat Risner has been working in the mining industry for 30 years, but it's not a career he initially planned.
It's like a lot of people that fall into the industry. There's no history of mining in my family. I was in college studying to be an electrical engineer.
And like a lot of college students, Pat needed to make some money on the side. Instead of doing what many students do, maybe get a job in retail or work as a research assistant, he took a less conventional route. He had some friends who were working in underground coal mines in southern Illinois. So he asked them to get him a job in the mine.
And knew nothing about mining and what I was getting into, and I went straight underground, worked in an underground mine, straight night shift on a crew, and I just loved it.
Pat still remembers the moment he traveled thousands of feet underground on that first night shift.
Yeah, it's a bit intimidating, but in a good way. Like, I was in awe. You get down there and you realize, I'm 2,000 feet beneath the Earth's surface. And just the ingenuity, the technical acumen, the resourcefulness of people to be able to create an operation like that in that environment. And it's like a little underground city with workshops and facilities and technology that people can't imagine. It's like another little world, and one that has had such dedicated and proud people. Those are the things I probably remember most.
Pat came from a sports background, so he immediately liked the camaraderie and the teamwork required to execute the complicated logistics in a mine. Very quickly, it changed the course of his career.
I went back immediately and changed my major to mining engineering, and as I started to learn more about the industry, I saw there was a higher purpose beyond just providing these really essential resources, both for our everyday life, but also for transformations that we're in the midst of, like decarbonization. And so it was really that higher purpose, but also the people and the way people work together in the industry that really struck a chord for me and has made it a lifelong passion.
Pat spent 25 years as an engineer, general manager, and executive at one of the largest mining companies in the world, BHP. Today, he's the president of the Hermosa Project, a mine in Arizona run by the global mining firm South 32. That mine is the only advanced project in the country that could produce manganese and zinc, two critical minerals that are essential to batteries and renewables.
South 32 is the world's largest producer of manganese ore in the world. We employ a little more than 9,000 people, and we're in the process of shifting our portfolio to a portfolio of commodities focused on metals that are important for a low-carbon future.
In this episode, produced in partnership with South 32, Pat Risner talks with Stephen Lacey about the importance of the Hermosa Project for America's clean energy supply chain and what it means to run a next-generation mine.
So sketch out the parameters of Hermosa. What are you doing there? Where is it located? How big is it?
So the Hermosa Project is located in the Patagonia Mountains in southern Arizona. So we're about 60 miles southeast of Tucson, only about 10 or 11 miles north of the U.S.-Mexico border. We have a world-class zinc deposit and a world-class manganese deposit. So it's the only mine development project in the United States that would produce two critical minerals designated on the U.S. Geological Survey's critical minerals list, so those being zinc and manganese. And it's also the only advanced mine development that could produce a battery-grade manganese to provide battery-grade manganese for the emerging U.S. and North American electric vehicle supply chain.
And the conversation around critical minerals tends to focus on lithium and cobalt, but manganese and zinc are both really critical for clean energy supply chains. And Hermosa is the only advanced project in America that can produce manganese and zinc. So talk about why these two minerals are so vital for clean energy specifically.
Yeah, so lithium and cobalt are a big topic because they are so important to electric vehicle batteries. But manganese is one of the ones that's often forgotten, but becoming increasingly important. There's manganese in the cathode of every electric vehicle battery. The typical electric vehicle battery right now has about 17% manganese. Manganese only constitutes about 1% of the cost. So it's a very low-cost metal in the chemistry of the battery. What a lot of these companies are starting to look at is for two reasons: increasing the amount of manganese that goes into batteries. So even if we don't change the way we make electric vehicle batteries today, manganese is essential, and we will need domestic supply. For us to achieve that, we're going to need domestic supply of all of these metals. But as the industry starts to look at using manganese more and more in the batteries, for two reasons. One is you can completely displace the cobalt in the battery by increasing the manganese content. The reason that's important is all the cobalt, most of the cobalt in the world right now comes from the Democratic Republic of Congo. So that's a challenging supply chain in a number of ways. We can produce manganese sustainably right here in Arizona and produce it with a local workforce, lift up a disadvantaged community. So we often talk about the opportunity of potentially displacing cobalt that's sourced from places like the Congo with Arizona manganese. And so in that case, the manganese could be as much as 65 or 70% of the battery. The second reason they're looking at it and why it's important is in low-cost electric vehicle batteries. So electric vehicle batteries in low-cost vehicles have a different makeup and a different chemistry. By adding manganese to that one, you actually increase the range of the vehicle, so how far it can go on one charge. So you increase efficiency at a low cost. And so that's why manganese is becoming increasingly important. Zinc is very much tied to renewable development. So zinc is used to galvanize steel. So as we build out wind, all the wind structures and infrastructures are made of steel, so it grows the zinc demand, but also associated transmission infrastructure. And we're even starting to look at zinc in battery storage for renewables to make it a full-time energy supply.
So we have a very proud tradition of mining in this country. And even though over the last few decades, regulation, automation, and geographic change have cut the number of people working in the mining industry, it's still a really important part of our character. But for some people, mining can bring up, conjure up images of environmental destruction and poor labor practices and communities, tribal communities specifically, that have been left behind. And the Hermosa Project is described as this next generation responsible mining project that takes a lot of these factors into direct consideration. So can we talk about responsible mining and what we mean by that term?
Yeah. I think where I probably should start is I talked about our purpose. Sustainability is at the heart of that because we have to do it right. Our approach to Hermosa is think about treating natural resources and the environment with care, being responsible stewards, and doing things differently, innovating and using technology and new approaches, bringing different approaches together to address what have been some of the typical sustainability challenges in the past. And there's a lot we can do differently as an industry. The way we think about that is minimizing impact on all environmental resources, finding ways to add enduring environmental value. So we have thought about that at Hermosa in a few ways. One is, how do we minimize impact on surface environmental resources? A lot of historic mining operations you see cover vast swaths of land, upwards of 10,000 acres, large open pits, big holes in the ground, large waste dumps, tailings facilities. We have devised Hermosa or designed Hermosa as an underground operation. We can mine both the manganese and the zinc resource with less than 600 acres of total disturbance, compared to upwards of 10,000 for many other mining projects. And the vast majority of that disturbance is on private land that was historically mined in the 19th and 20th century. So it's actually not new disturbance. So minimizing surface impact, and the reason that's important is reduce or minimize impact on biodiversity. Our company has a no net loss goal for new projects. And so our efforts to minimize surface disturbance and the way in which we're doing that is really important. The second one is water. Water is a precious resource everywhere, but we are in the desert Southwest. There are scarcity concerns, obviously, everywhere. So it's a resource that we have to be good stewards of. One of the first things we did when we acquired the property is there was a lot of historic mining waste from the late 19th, early 20th century. We built what's the first dry stack tailings facility, new dry stack tailings facility in the United States. So this is a new way of managing the waste or the rock that comes out of the processing of the mineral resource, where you actually pull the water out of it and you can reuse the water in the process. and the tailings then are placed in a dry state. That significantly reduces the water intensity of the operation. Our water intensity will be about 10% of a lot of the major mining projects proposed out there today as a result of that. And then being an underground mining operation also adds some benefits to water use. I think understanding the cultural landscape and resources, you talked about tribes. One of the historic challenges is tribes aren't involved in the right way in these projects. They aren't engaged early enough. 4 years ago, before we even started the pre-feasibility study on this project, we started proactively engaging up to 14 different Native American tribes. We aren't on tribal lands, but there are tribes that had historic affiliation in the Patagonia Mountains. We began engaging them 4 years ago. At that time, we did all the cultural resource inventory on all of our land packages so that we could understand the cultural landscape and resources while we're planning the mine. Because at that point, we can think about avoiding, and we have a much better opportunity to design the operation in a way to minimize any impacts. We've been transparent, shared those results with the tribes. So those are some examples of some things that we're doing differently that I think speak to what responsible next generation mining looks like.
And then how about how that translates into hiring practices in terms of hiring locals in the community, creating a local economic impact? What are those impacts you are pursuing?
Yeah. Well, the biggest thing we can do right up front is beyond things like social investment and infrastructure as part of developing the project is to have a local workforce and procure locally. So we have some commitments around that. We've communicated to the local community that we believe the long-term workforce at Hermosa could be 80% or greater people that live in Santa Cruz County today. I talked about earlier, it's one of the poorest counties in Arizona, a per capita income of about 40% below the state average, about 800 to 900 permanent jobs associated, South 32 jobs associated with the project. If you look at vendors, suppliers, contractors, and induced jobs from increased disposable income, that number's in excess of 2,500 jobs. So there's a real opportunity. What will be incumbent upon that is we're about to launch into a significant local workforce development program to start training people that live in Santa Cruz County now to do these roles. And because we're extensively using automation and technology, we can train people that have no mining experience to do a lot of these jobs. So we believe we can be over 80%. That has a significant impact from a socioeconomic standpoint on the community. Every job at Hermosa generates 2.5 times the current average household income in the county. So you think about 800 to 900 of those, it becomes potentially transformational.
So a lot has changed in how these mines are operated technologically. So when we call this a next generation mine, what does that mean in terms of the technologies and practices inside the mine?
Some of it's the sustainability practices that I talked about earlier. So things like dry stack tailings, doing backfilling underground. So the underground mining method we'll deploy, we will actually take half of the waste stream that comes out of the processing facility and it will go to backfill the areas underground. That helps us minimize surface disturbance, but also obviously helps us maximize recovery of these critical mineral resources. I think part of the piece that's really next generation is what we're looking at in terms of automation and technology. So we will, and we've announced this to the community, we will be building a remote operating center, and that facility, from that facility, we will remotely operate parts of the production process underground. So the underground mine, 30 miles away, 3,000 feet underground, equipment and production processes remotely operated from a remote operating center that sits closer to the population center of the county. That's essentially an office environment or like a command center. Some of the processes will be fully automated, some remotely operated from there. We can remotely operate things like the processing facility from that area. That's what's different. So we have people sitting in an office environment like a command center, operating the equipment underground rather than a person sitting on the piece of equipment underground. A few advantages of that. One is it will help us hire locally because we can train local people without mining experience to do those jobs. Two, that facility sits near the population center, and we have aspirations to increase the diversity in our workforce as well. What that means is a workforce that's reflective of our local community. Our local community's 85% plus Hispanic Latino population, but also increased gender representation. So females have been underrepresented in our industry for a very long time. With the use of technology like this, with the changing in the way in which we work, having things like the remote operating center, we believe we can significantly increase the female representation in our workforce, and our workforce better reflect the local community where we operate. So that's kind of tying together what next generation mining looks like, but also around our social aspirations for the project as well.
So it can be hard to build large critical infrastructure in this country, but America does have a process for accelerating some of those infrastructure projects called Fast 41 that was established by Congress in 2015. And Hermosa is on the Fast 41 list. What does it say about the Hermosa project that it is on this list?
Yeah, I think so. Hermosa is the first mining project ever to be added to the Fast 41 program. That was announced back in May, even though mining's been a covered sector for a while. I think it's three things, and it goes back to some of the previous themes. I think the criticality of these resources is one. The administration's focus on electric vehicle deployment and build out of renewables. But I think the element that really adds to that is we are so highly reliant on foreign supply chains for these two resources. Virtually all of the battery grade manganese in the world, it's like 99%, comes from China. 97% of the manganese metal in the world comes from China. We are highly reliant on Chinese refining for zinc, and the U.S. hasn't mined manganese in 50 years, since the early 70s. So both of these resources have challenging foreign supply chains. And so what Fast 41 does is it really provides predictability, coordination for the federal permitting program to provide that certainty. And the reason that's important here is the certainty of creating those domestic supply chains and having continuity in those domestic supply chains, so we're no longer reliant on foreign sources for these metals that are essential for a clean energy future. The second reason, I think, is the way in which we're proposing to develop the project. So low carbon design principles. We're designing this as an operation that can contribute to our company's goals of net zero operational greenhouse gas emissions by 2050. So renewable energy to power the mine, battery electric fleets underground and on the surface. So we're developing a roadmap or a pathway to be able to develop this in a low carbon intensity way. I talked about dry stack tailings and water and small surface footprint. So all of those environmental and sustainability credentials, I think, are the second reason why. And then lastly, being able to produce those critical minerals and lift up a community that has been historically disadvantaged, I think, is the third reason. So when you look at all three of those things, it's a tremendous opportunity to address a need the nation has to meet its decarbonization goals, but do it in the right way and lift up a community in the process.
Do you still get the same thrill from mining that you got when you first went underground?
I think maybe even more so, seeing how it's changing. I've probably spent a lot of my career where it was perceived as, a 19th century industry and things like that. And so yes, but in a different way. Like when I see our team, working through exploration challenges and using things like machine learning, involving people with very different skill sets to what we ever did. It's something I couldn't have probably imagined 30 years ago, but it certainly does make you proud about where the industry is going, and the ability to draw more people from more parts of society into the business because we do things in a different way is very exciting for me. So yes, but it's coming in a different way because of how our industry is evolving.
Well, Pat, thank you so much.
Thank you. Thank you for having me.
Pat Risner is the president of South 32's Hermosa Project. To learn more about how Hermosa can help power the nation's clean energy future, strengthen the domestic supply chain of critical minerals, and grow the local economy in Santa Cruz County, Arizona, go to south32.com/Hermosa. Or you can follow the link in the show notes. There you can read about the next generation mining practices and find updates on how the project is progressing.